Hi, my name is Gregory Light. I'm a technical account manager for AVL Mobile Technologies Incorporated. A distinct difference between the traditional, let's say OEMs and tiered companies that have been around for a very long time. They have established development processes and methods that have worked, well. In comparison to the startups, they're visionary. So they tend to be more aggressive, more risky, more open, and they develop their own methods and processes, which are good. There's quite a few startups out there that are very successful. So when we talk to them, it's a two-way street where they learn from us, AVL, and we learn from them as well. That's the great thing about engineering and research and development. It's research and development. You're always trying to get a new process or development method that's quicker, better, faster, more robust. So you really do have to be open and to changing, adapting, staying in the forefront of whatever industry that you're in. That's what's nice about our simulation tools. It allows our customers to explore those different paths to get those results. So it's nice. You do see a difference, but it's nice to work with the different customers and their different methods and processes with our solutions. What I like best is customers coming to us and they have a challenge to meet some goal. They want to develop something new, the latest and greatest, or they have a problem in their current product or process or method. And the best part is working with a customer, listening to them, understanding what their need is, what their challenge is, what their goal is, and then AVL putting together a solution, whether it be something small or big, and then delivering that solution to the customer. In some cases, customers can go on their own and use the solution and they find the result they need and it's good. But other cases, AVL likes to collaborate with its partners, its customers, as partners, and work with them and discovering the goals or the results that they're trying to achieve when they address these problems and challenges and get a solution. And just seeing a customer being satisfied that, hey, this is what we were looking for, this is what we needed, and then hearing the big benefits that they're reaping, getting a project back on its proper timeline so it's not behind anymore, or being able to bring the project, accelerating it so it's getting done quicker and faster. We have one solution where we present it to a customer and they're up and using it within a day, and they're getting results that ordinarily would take them days or weeks or even longer. And so when you get that kind of feedback from the customer, it's very satisfying. Makes the job well done, easy to come to work.
Yeah.
In a year, but definitely in the future, in regards to virtualization and simulation, I would see the implementation of a lot more AI-based methods for testing, data processing. I would also see, this is, I think the next phase would be like more virtual reality or augmented reality. We see that coming into the maintenance world. I see in the engineering world where traditionally engineers they're sitting in front of a monitor and they're looking at data and processing things. And I see it where it might go into augmented or reality world, reality or virtual world where instead of being confined or compartmentalized onto one or two monitors, it can be up in a space and they can manipulate things and they can see more of a global aspect of, hey, if I make this change over here, how it's going to affect the broader picture. Whereas when you're confined to a small space, you're limited to what you can see and what changes you're making, what effect it's going to have. So I really think that the next level would be adopting virtual reality or augmented reality in that research and development process. Beyond that, I think another next level would be quantum technologies. As quantum computers get more mainstream, not just the processing, but firmware and integration, it's really accelerating. I think when we move away from the traditional PC to more of a quantum technology, you'll see things rapidly accelerate as far as engineering goes, and the processes will change due to that technology as well. So there's a lot of technology out there that will affect how engineering goes on in the automotive space, the aerospace, agricultural, marine, and pretty much any mobility. So I see those technologies affecting those other industries as well. That state doesn't have to be a 1 or a 0 anymore. It can be a 1 and a 0 at any given moment, thereby allowing a lot more processing to occur and happen. Very unique. But if you look at some of the current quantum systems right now, they're very complex. You can go on the internet and hit any search engine and type in quantum computer and you'll get a few of them from some pretty big companies. And click on images and you can see what they look like. They're in very controlled spaces and have lots of cooling that goes on with them. But the way the information, the data is processed is completely different than your traditional computing now, where it's either a 1 or a 0. In quantum computing, it's a multi-valued state of data processing and data handling. It's kind of like you would say like a light switch, it's either on or off, right? But in quantum computing, it's actually processing the in-between too. So there's a lot of information from that. So I think that's the most simplest way I could describe it. Of course, it's a lot more technical than that, but yeah.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.